Hi, welcome back to the channel. In this lesson, we'll see how to integrate cos squared of x. It will help us revise our basic trigonometric identities and also how to use function of a function in differentiation. That said, let's get into class. Now, like I said, we'll be seeing how to integrate cos squared of x. That is, I'll be looking for y. I have y to be equals to cos squared of x with respect to the x. The first thing we want to do is to find a conversion for cos squared of x. Now, remember that squared of x plus sine squared of x is equals to 1. And also remember also that cos 2x is the same thing as cos squared of x minus sine squared of x. Now, so that if cos 2x is the same thing as cos squared of x minus sine squared of x, from here we can make an expression for sine squared of x. So that sine squared of x is the same thing as 1 minus cos squared of x. Then my cos 2x obviously will be the same thing as cos squared of x minus, I have a large bracket, 1 minus cos squared of x. I've simply substituted for sine squared of x. So that my cos 2x again will be the same thing as cos squared of x minus 1 plus cos squared of x. So that cos 2x now will be the same thing as 2 cos squared of x minus 1. Now, from here, I can make a formula for cos squared of x. So that my cos squared of x from there will be the same thing as cos 2x plus 1 all divided by 2. So I can now substitute for cos squared of x, saying y now will be equals to the integral of cos 2x plus 1 all over 2. I'm integrating with respect to what? To the x. Let's break this down further. So that my y now is the same thing as half integral of cos 2x plus 1. Everything with respect to the x. Now, like we do in normal integration, I can begin to reduce this. So that y now is equals to half now into integral of cos 2x plus integral of 1. Integral of cos 2x will be respect to the x. Integral of 1 also is respect to the x. Now I can easily integrate each of these one after the other, or you can do them together depending on your convenience. But for me, it's convenient for me to actually break them one after the other. So let's pick the integral of, let us solve for the integral of cos 2x with respect to x. So that in solving for that, I want to say let u be equals to 2x. So if u is equals to 2x, my du dx will be the same thing as 2. So that the x from here will be the same thing as du over 2. I can easily substitute in here. So that the integral of cos 2x with respect to x will now look like the integral of cos u dot du over 2. So that when I integrate this becomes half here sine u plus c. So that automatically this is half. Remember we said u is equals to 2x. That is half sine 2x. Next again, I can now integrate. Remember we had the y to be equals to integral of cos 2x with respect to the x plus integral of 1. Next now, I want to integrate for 1. So that obviously integral of 1 with respect to the x is the same thing as x also plus c. Now I can now merge both results together. Remember that my y is equals to the integral of the integral of cos 2x plus the integral of 1 with respect to the x, so that my y now will now be equals to, I've gotten the integral of cos²x, that will be half into half sine 2x. This is 2x, is 2x, plus integral of 1 also is x, and close my box, plus c. C is a general constant. Now, so that my y now will be equals to half times half, that's 1 over 4 sine 2x plus half x plus c. With this, I hope you understand how to integrate cos² x. Thank you for staying with us, and see you in our next class.